Hey guys, Mr. Betts here. I want to take a look at a couple examples using the fundamental theorem of calculus and the chain rule. So in this example, this would be a really easy problem. It'd be pretty straightforward if this was just an x here, because our answer, we would just take the x and plug it in for t, and it would be the square root of sine squared of x. However, since it's an x squared, we're going to treat this as an inner function. So one thing we could think of, you definitely don't need to write this out in your work, but we could think of redefining f as, say, h of x, and h of x is going to be, let's say, x squared, and then this right here is just h of x. So what we really have here is f of h of x. And so that means we have a composite function, we have an inner function. So the way you're going to think about this is that x squared is an inner function. So we're going to take the derivative like we normally would. So f prime of x is going to be, so the way we would normally do this with the fundamental theorem of calculus is we would replace the t here with an x. So we would have the square root of sine squared of x squared. But then, since it's a chain rule problem, this x squared is the inner function. We have to multiply by the derivative of the inner function. So we're going to multiply by 2x. Now, this is just a notational thing with square roots. If you multiply by something at the end of a square root, it's sometimes hard to tell whether it should be inside or outside. So generally, you want to make sure it's clear by putting it in front. That's something else we would do with like trig functions, or make sure you use parentheses appropriately. You're not going to lose points as long as your answer is correct, but if you would put the 2x at the end and it's underneath the square root when it shouldn't be, that would definitely be bad. But the important thing here is we are using the chain rule because that x squared is a function. So we have a function within a function, and so we have to use the chain rule there. Also notice that the 12 down here, it didn't really matter that it was a 12. The only thing that did matter is that that is a constant. It's just some constant number. So we need to make sure we keep that in mind. So in this problem here, this one's really similar. We're taking the derivative of a function. So this is the same type of problem as the last one, just written in a different way. So we could have said, set this problem up by saying this is f of x. So f of x is equal to this. Find f prime of x. So instead of that, we're just making it more succinct, more compact. So we're taking the derivative of this. And again, we have a constant as our lower limit, but we have a function as our upper limit. So with that function, we do have to use the chain rule. So this is going to equal, so we're going to, again, do this the same way we normally would to start with. So the sine of x is going to go in for t. So we're going to have e to the 2 sine of x. And then we have to multiply by the derivative of the inner function, what I call the baby function sometimes. So the sine of x, we're going to take the derivative of that and get cosine of x. And again, just to make sure that it's clear what's in the exponent, what's not, I'm going to put that out front. It certainly wouldn't be wrong to write it like this, as long as it's clear that the cosine is not in the exponent, but the sine of x is in the exponent. Either way is okay.